In this video, I'm going to talk to you about equations of tangents and normals from a curve, assuming that you already know the rules of differentiation. So we'll just remind ourselves of a tangent, of the definition of a tangent. So a tangent is a straight line that cuts through a single point on a curve. And what we can say about the tangent and the curve is the gradient of the tangent is identical to the gradient of the curve at this single point, this x value. Now let's talk about a normal, the normal to the curve. Well, the normal to the curve, the normal, the line, the normal, it's because the line, is the line that cuts through the tangent of the line, hang on, got to get this right. Now let's talk about what the normal of the curve is. So if we look at this particular tangent here, the normal of the curve at this point cuts it exactly 90 degrees. So if I draw a dotted line to represent the normal, what we can say is it cuts the tangent perpendicular at that point. Now that means that the gradient of the normal is at -1 over whatever the gradient of the tangent is at that point. And that's how we talk about the normal on the curve. Now let's go into some examples and find the equation of the tangent. So what I'm going to do is just pick an example, 2 seconds. Alright, so what we're going to do is we're going to find the equation of the tangent on this curve at the point when x is 1 and y is -1. And we'll also find the equation of the normal at this point as well. So, just a reminder that any straight line follows the equation y equals mx plus c. Alternatively, you can use the other equation that's often used for a straight line, which both of them give the same answer, all right? But basically, I'm going to use this method because this one's most common with my students. So what we need to remember also is the tangent, the gradient of the tangent at this point to the curve has the same gradient on the curve at that point. So let's differentiate this function. So dy dx is 3x squared minus 4x. Now at x equals 1, this is where our tangent lies, we can find the gradient on the curve. So the gradient is 3 times 1 squared minus 4 times 1, which is 3 minus 4, which is -1. That's right. So our gradient is -1 at the point when x equals 1. So what I can now do is substitute that into this formula to find the equation of the tangent. Negative x plus c. I have a coordinate that both the curve and the tangent goes through. When x is 1, y is -1. Oops. So I can sub that into this to find the y-intercept. So -1 equals -1 times 1, which is -1, plus c. -1 plus 1 gives us 0. So our value for the y-intercept is c. Is 0, apologies. So our equation of the tangent is y equals -x. Now let's have a look at the equation of the normal. Well, looking at this, we'd still need to follow the same process. We would need to find, well, what is the gradient on the curve at that point, which is the same as the tangent at that point. And then what we need to do is apply the formula. So of course the gradient is now -1. We now need to apply the formula for the equation of the normal as -1 over the equation of the gradient of the tangent, which is -1 over -1. So the gradient of the normal is 1, which has just popped off the bottom of my screen. Now I'm going to use this, I'm going to follow the same method now to find the equation of the normal. It's still a straight line following the rule y equals mx plus c. So let's go y equals 1x, or just x, plus c, and use the same point because remember that coordinate goes through the normal as well. So at x equals 1 and y equals -1, we get 1 times 1, which is 1, plus c. Subtract that, c is -2. Therefore, our equation of the normal is y equals x minus 2. And that's pretty much everything you need to know about finding the gradients of tangents and normals on a curve and being able to apply that to y equals mx plus c.